1 to 9 are placed in the bag. One ball is taken at random. What's the probability of the number is odd? So we've got numbers 1 through 9, so we have to establish how many of those numbers are odd. So how many of the numbers are odd? 5. And how many numbers are in the bag? So that would be 5 over 9. Yes, I think everyone got that. That was good. Right, calculate the values of the following. Okay, so we've been told 3 values. What did I say we should always do when we have these kinds of questions? Right, use the bracket. So your first step should have been to just literally write the number using a bracket. Now, some of you didn't do that, and some mistakes were made that could have been avoided if you used the brackets. Okay, you had your calculators available to you, and then you should have been using your calculators as well. So I would have written for this one 3 bracket 3 take away 2, just like that. So the value of the B was 3, the value of the C was a 2. I put them in my brackets. I then would put them in my calculator. Now let's. All right, so we're now going to stick that on our calculator. So 3 bracket take away bracket 2 equals 7. So our answer was 7. Second one, what value is sticking in here? 1. Thanks, Georgie. Now, here's the problem for some of you. The squared sign goes there. What is being squared here? Just the 1. Now, some of you did 5 squared because you did 5 multiplied by 1. Remember, we're always using BEDMAS, which is why I'm trying to encourage you to use the calculator, because the calculator knows to always follow BEDMAS. So if we chuck it in the calculator, we'd have 5 brackets 1 bracket squared is 5. Okay, next one. I've lost the numbers now. So bracket 3 plus 3 bracket 2 bracket, and then a 3, chucking it in the calc. Oh, I want to do. Bracket 3 plus 3 bracket 2 bracket to the power of 3. 729. Okay?
I don't remember how many times I checked the 729. It's such a big number.
Now, but can we appreciate how quick was it to just write this, chuck it in the calculator? Yes? Remember, we are supposed to be, we generally allow you 1 mark per minute. Now, that took way less than a minute, so that gives you extra time for some of the other questions that might take you a little bit longer, okay? So you've got to be smart when you are choosing how you're doing some of these things. So if you're spending a long time trying to work these things out in your head, there's no need to. As long as you're showing me this set's working and then this, you're going to get the full marks. Now, some of them will ask 2 marks, so you get 1 for showing me this. That's all, like 1 mark just for writing that. Brilliant, even if you made a mistake when it came to the calculation.
Can I get the right answers?
Of course you can, yeah. Because I think they were already worth 1 mark. Well, okay, we'll sort out individual questions in a minute, okay? So, last one, the square root sign, b squared. So we've got bracket 3 squared minus 4 bracket 1 bracket 2. Here we've got to make sure that our square root sign goes over all of it. Oh, that's annoying. So we've got a square root sign, and we've got a bracket 3 bracket squared. Take away 4 bracket 1 bracket 2. Okay, we've checked that our square root sign goes over all of it. We get the answer of 1. Okay? Lovely chocolate. So the probability of drawing pin landing face down is 0.37. What is the probability of it landing face up? How do we do this, Maya?
You use 0.1. Well, 1.0 or just 1. Subtract 0.37.
Good girl. Why would we do that? Where does 1 come from?
Because 0.37 is out of the 1 whole. How many times it?
I like it how they explain it sometimes, isn't it? You've got the right idea. Keep going though. So that's the probability of it landing face down. Why did we do 1 subtract that value? What do we know about probability?
No.
What does probability always add up to? 1, yes? So we know that the probability of the whole thing happening always has to add up to 1. And so we've got the probability of landing face down. So if we want the probability of landing face up, we're just going to find the difference between those two numbers, aren't we? Okay? So whilst you knew exactly what to do, it's quite hard to explain it, isn't it? But I'm going to try and encourage you to do that wherever you can, to try and explain where you're getting these answers from, because that really makes sure that you understand why you're using the numbers.
It's like 1 in my face 1.
Exactly, yes. You know the value of one thing, we know that the rest of it must make it up to 1, so we do the subtract. So that's 0.63, okay? Again, we could have done that on a count if we needed to. So, simplify the following by collecting like terms. Now, some of you are struggling a little bit with your signs, so you really do need to work on your integer skills. Now remember, I printed off those sheets and sheets of questions for the integers because you all wanted some practice on that. So we need to make sure that we have been practicing that. Now your calculators can help you here. Obviously you can't enter the letters because your calculators are basic calculators, but you can use it to help with the signs if you're not too sure. The important thing is we need to identify like terms. So I'm looking at my 8x. Is there anything like 8x? Madison?
Positive 2x.
Good. Positive 2x. I'm glad you said the positive part because I'm including that in my symbols. Yes? So I can now read 8x plus 2x. Yes? What does that give me, Abby?
10x.
10x. Lovely. Right, that's what I read. I've now got what's left here. What's this term here, Fasika? What's this term here?
Negative 2y.
Good girl. Negative 2y and positive 5y. So if we weren't sure about it, in our calculator, we could type in negative, because remember we're using the negative sign, 2 plus 5. Okay? So it was negative 2y plus 5y. We can't put the y's in, but we can put our values in. So that gives us 3. Now, is that positive or negative? Positive. So we're then going to write plus 3y. Okay?
Oh, I didn't know.
So I saw lots of no recognizing like terms, but it's just making sure that we've got those calculations correct. That's meaning some of you are losing marks there. All right. So the second one, we've got 3y squared minus 5y minus y plus 4y squared. Well, they all look like terms to me. Are they all like terms? Georgie, what's not like? Or which ones are like and which ones are not, and what makes them different?
3y squared versus 4y squared and negative 5y versus.
And why are they different? Awesome, lovely. So there we go. Done colours. So happy with that?
Yeah.
So I've got my 2 colours there. So I know what I'm joining together. So I've got 3y squared plus 4y squared. Now lots of you fell into the little trap here and you said that it was going to be y to the power 4. So we've got to be careful with that. Remember, like terms, when we're adding or subtracting, those letters, the combination of letters don't change. Okay? When do they change? When would the powers change? Yes, we're multiplying. All right, so you've got to be careful when you're doing that. So we've got 3y squared plus 4y squared gives us 7y squared. Good, I'm not even putting that in the calculator. All right, this one's a little bit trickier. What values are we sticking in our calculator now, Madison? What would we stick in the calculator to help us do this with? You can use this to help.
Negative 5y.
Now, can we put the y in?
Oh no, sorry, negative 5. Subtract 1.
Good girl, awesome. Subtract 1, because remember with this letters, there's a secret 1 there. And we've got just subtract 1. We're not taking away negative 1, okay? Because we've got negative 5, take away 1, all right? So negative 5, take away 1 is negative 6. So we're then going to write take away 6y, okay? So can we see how the calculator can help us here? Yes?
I did minus.
You did take away negative. Yes, and you wrote plus.
Minus, I did 7y squared plus.
Yeah, so I think that's what you did. You saw that there was a negative, they were both negative. And remember, I keep trying to say to you all, try and get out of your head two negatives to make a positive, because that phrase just messes things up when you're adding and subtracting. Okay? It's when so if you had to take away negative here, that does then become a plus sign. Yes. I don't know, darling. I think because you added on the 1 rather than took it away. There's lots of mistakes that people are making, but if we can see how, I don't always like to rely on the calculator, but you have it there, so why not let's use it, okay? If we use it and get the right answer, I would rather that than make a silly mistake and get the wrong answer. All right, so now we're back to probability. An 8-sided dice has its faces, blah, blah. Find the probability of rolling a 5, and I think everyone got this right. So there were 2 5s, and there were 8 sides, so it was 2 out of 8. Did you have to simplify it?
No.
No. If you wanted to, you could. You did. So 2 out of 8 is fine. A 7. What's the probability of getting a 7? Sarah, what's the probability of getting a 7? 0. Yep. You didn't need to write over 8. You could just write 0. Okay? Because there were no 7s. All right, we're flying through it. Expand the brackets and simplify if possible. Okay, so we've got to be careful here. Remember, when we're expanding, the value that's right next to the bracket is what's being multiplied by the bracket. Anything separate, so before it separately or after it separately, is nothing to do with that expansion. Okay? Sarah, do you have a question that you're going to ask? Sure.
So if you 5a plus 25 take away a.
Okay, let's go a bit slower. So we've got 5a plus 25. So we did there 5 multiplied by a, and then 5 multiplied by positive 5. So that gave us the 5a plus 25, and then we've got the take away a stuck on the end. So I think these were worth 2 marks each. So if I'd seen that, you would have got 1 mark. You've got to be careful, because if you're just showing me parts of questions and missing bits out, I can't always award any marks. Now we've got to go back to remember about joining like terms, because we can see that we've got a 5a here and a takeaway a. So we would join that together. Sarah, how would we do that?
You would do 5a take away a, give it 4a, and then you would plus 25.
Love it. Okay, bless you. So can we see how that all works? So I've tried to colour code to help. So we've got the red expansion, the takeaway A was still there. We've joined our like terms in the green, and then we've just got the plus 25 left. Okay. Next expansion. So we've got 2 different brackets here. So I'm going to do it in 2 different colours. So I'm going to expand this bracket with the red. So we've got 2x plus 6. Now, here's the tricky thing. What value is this in front of the bracket? What's the value in front of the right-hand bracket, Jane? It's negative 3, isn't it? So we've got to be careful when we're expanding this one. So we've got negative 3 multiplied by x. I think everyone was happy and wrote negative 3x. This bit is where some people made some mistakes because we're doing -3 multiplied by
-4.
-4. And what does that give us? When -3 is multiplied by -4, let's see again.
I made -4.
What should it have been? -3 multiplied by -4. What's 3 multiplied by 4? Multiplied. 12, and then you've got, and they're both negative. So what did we say when it's the same sign? Yeah, so it should have been plus 12 here, okay? So again, if I'd seen that, that would have been worth 1 mark because you've expanded both of those brackets properly. Now we need to join like terms, so we have a look to see if there's anything alike. Maya?
The ones that were like and sorry, and like this.
Yep.
So the exact size here, and then go to positive 6 plus 6, which is 8.
Good girl. So 2x take away 3x. If we're not sure, let's put it in our count. So we've got 2, and we're taking away 3, gives us
-1.
-1. So that's -1. I don't mind you writing -1 in your working, but really we should then get rid of the 1. Okay? Joining our numbers, our black numbers, Maya already told us that was plus 18. So our final answer should have been -x plus 18. Or 18 subtract x, both are the same. Okay, next one. We've only got one bracket we need to expand here. So that's this one here. Madison, how will I expand this bracket? How do we expand it? No, the bottom doesn't.
X squared.
Yes, because it's x multiplied by x, so that's x squared, and then what do we do? Well, let's have a look. We've got, what do we have to work out?
7x.
Good girl, plus 7x. Alright, still happy with that?
Yes.
And then, do we have to expand anything over here on the right-hand side? No, there's nothing, there's no bracket, so we just write plus x squared plus 3x. Okay, so I've kept it in black because I haven't done anything to it. Now what do we have to do? Georgie? Simplify it, and that means we're joining the like terms together. Again, some people made some of those mistakes when we're joining like terms and we change the powers of them. So here we've got x squared plus another x squared. What does that give us? Careful. Good girl, Georgie. 2x squared. Remember? There's one of them here, there's another one here. That means we've got 2 of them. And then, Abby, what's the last thing we're going to do?
So we're going to combine 7x and positive 3x.
Good girl, what does that give us?
Plus 10x.
Awesome. Okay, and the last one here, this 5. What are we going to do about this 5? Is he involved in any kind of expansion?
No.
No, so we leave them alone to start with. What value are we multiplying the bracket by, Maya? Adam? What value are we multiplying the bracket by? Good girl, -3. Just want to make sure you're all happy that it's -3. So we're doing -3 multiplied by 2x gives us good girl, -6x, and then we do -3 multiplied by, which gives us positive 21. Good girl. Okay, you all happy with that? And then what do we have to do? We have to join like terms. Are there any like terms? You sure? Is this not like this? Yes, there's 2 numbers. Okay, so we've got to remember that that little 5 was there. So that's going to be 26 subtract 6x. Or -6x. Alright, so complete read the table below to show the outcome. So we did some of these, didn't we? They've given us one example, so that's really helpful. So it's just going to be 2H, 2T, 3H, 3T, and so on and so forth. Okay, so you've got 2 marks for getting that whole table correct. Now, find the probability. Oh, perhaps I should. All right, find the probability of getting a head and a 6. So how many of these up here are a head and a 6, Georgie?
There's one.
There's 1. Okay, so this one here, head and a 6. Now, lots of you were fine with that part, but the denominator boxed some of you. And I'm wondering if it's because you hadn't counted properly. Remember, the bottom number is how many possible outcomes were there. So we look at our table and we say, right, there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. Do you all see that? So our denominator should have been 12. You simplified what, darling?
No, because you think that we simplified it?
Simplify what? 1 out of 12. We can't simplify that anymore, sweetheart. One doesn't go any smaller.
Maybe 0.5 over 6.
Yeah, you can't simplify that because it's 1 over 12. All right, here, a tail and an even number. A tail and an even number. Right, so we go through and we say which ones are tails and even numbers. Yeah, even. So this one's a tail and an even number. This one's a tail and an even number. And this one's a tail and an even number. So how many of them were there? And this one again out of 12.
I got a point.
So yes, I gave people 1 point for this. I do need to look into whether, whichever number you had here, if you had the same number here, I may be able to give you another one, but we can talk about that afterwards. Okay, so back to it. All right, this is where some people were struggling. It's a tricky concept. Important word that's underlined is fully factorized. So we have to make sure that anything that's common has to be brought to the front. So 6x minus 9. The numbers, anything that's there's no x common to both of them, so that's not going to be common. There's a number that's common to both 6 and 9, and that's a 3. So looking at the method we were learning, so that's 3 multiplied by 2x, and, oops, take away. 3 multiplied by 3. Our 3 was our common number. That goes to the front, and anything we didn't underline goes inside the bracket. So 3 was common, and we're left with 2x minus 3. So looking at the next one, are there any letters that are common to both sides? Georgie? Well, letters, yes, so the answer is yes, there's a B. And 7 is also common, as Georgie just said. So what we're going to do is change 28 to be 7 multiplied by 4. And 21 would be 7 multiplied by 3. And so our 7 and our B are common. And we're left with 4a plus 3. And our last one, let's expand this out. Well, are there any numbers that are common to 18 and 12? Trying big numbers? Yeah.
The numbers that are common are 6.
Good. So 6. So we're going to change 18 to be 6 multiplied by 3. And a squared b cubed. How would we write that? Or did you do it differently?
I just did it 6 times 3, a.
That's exactly what I was looking for. A, B, B, B. And then we'd have take away 6 multiplied by 2. Bless you. A, B, B. Okay? So we're looking at these things. What's common? Well, we've got a 6 that's common. We've got, how many A's can we underline? Just 1. And how many B's can we underline? 2, yes. Okay, so we've underlined the things that are common. So at the front, we're going to write 6 AB squared. Remember, we go fancy pants when we are writing to the front. What we haven't underlined is our 3, our A, and our B. Take away 2. That's all we're taking away there.